Hey guys, what is up? It's your pal Dave back again, live in the lab on a Sunday. And we got some people in the chat already. Some familiar faces: Joseph, Casey, Drew, welcome back. So Sunday seems to be a good night for me to do this. I have a little time, so I thought I'd do some fun stuff today. What am I going to do today? So I'm getting a lot of comments. Most of my Arduino stuff has been about the Uno. What's that, Caboose? You better read the comments. I want to be loved. You are loved, sir. Don't worry about it. Joseph, hello, welcome. So a lot of people are sending me comments saying, what about the Nano? The Arduino Nano. So the issue has been, I haven't owned one of these until today. So I just picked up a couple today, and it's pretty cool, like from what I can tell. So we're gonna play with it today and build a MIDI controller with this guy, or we're gonna try. And hopefully it's all gonna work out. So apparently this is pretty much Uno compatible. And the cool thing also is it has 8 analog inputs, whereas if you know the Uno only has 6. And another person commented, can I make an 8 pot controller with a Nano? And I'm thinking, sure, probably. Why not? So that's what we're going to try to do today. And if it all works, we're going to try to hook it up to Ableton through a MIDI interface. And if that all works, wow, we're doing well. So first, right off the bat, this is a 5-pin MIDI project. It is not a USB MIDI project. So this is how we're going to connect it up, all right? And on your computer, if you have an audio interface or a MIDI interface that accepts one of these, that's how we're going to connect it up to Ableton, if all works. All right, so just be aware of that. So here's how I got my Nano from the store, and I basically got it. It comes in a little kit here, and they give you some headers. Let me give you a better view here. Okay, so we got our little Nano. They give you the headers separately, and it's pretty easy to solder these together if you haven't done it. But one thing to really keep in mind is you got to make sure these headers are straight, right? So when you put them in, they flex a little bit, right? You got a little bit of play. So if you solder them and they're kind of angled out like this, it's not going to fit into your breadboard at all. So what you should do is get a little breadboard, put them in all the way in, the headers, and the long side goes into the board, the short side goes into the Nano. And then once they're in, that's going to keep them straight. And then you can put make sure it's the right spacing. Yeah, that's it. All right, so once they're in, you can stick your Nano on top, and then take your soldering iron and some solder and carefully solder these pins. They're very small, and that's going to keep it all straight. So when you pull it out, it's going to be perfectly straight and will fit into a breadboard perfectly. So other than that, simple to do. They also give you a little programming header, right? And we're not going to use that. That's if you want to use an external programmer, all right? But we're going to go through the USB to get this running. Okay, so there we go. And like those cooking shows like Julia Childs and all that, they always have one pre-done. So I've already soldered one up, so we're going to use that. Saves a lot of time. And what else was I going to say about that? Oh, yes. So one thing, this is not an official Arduino one. Okay, I got these off Amazon, and they're super cheap. They're clones, and honestly, they're less than $5 each. You know, so really cheap. The only issue is I've had some people say in the Amazon comments that some versions of this, the cheap knockoffs, they don't come bootloaded properly. So if that's the case, you would need to use the external programmer to get a bootloader on it and get it up and running. Luckily, I found these guys came all ready to go, so I didn't have to do anything, which is really good. So that was handy. But if you're having trouble, you may have to do a little searching online, and you may have to pick up a external programmer to get this going. Okay, and I'll put a link, an Amazon link, in the video description when I write it to exactly what I bought, these exact ones. And I'm an Amazon affiliate, so if you click that link and buy some of these, I get a couple of pennies. It helps keep me stocked in wires, so it's really appreciated. Okay, so let's get started. So we're going to take our Nano, and we've got one of these breadboards, and we're going to use two because I got to wire a lot of stuff. And I always get these, which are really cool because they actually slot together, so you can make like bigger breadboards out of these little ones, and it helps as your project expands. You can make them bigger, right? All right, so first of all, we'll stick our Nano right at the edge. All right, and there we go. So what do we have to do? We got to build some stuff. So we have to add a MIDI jack. We have to add some potentiometers, and we have to add some buttons. And we're going to try to make a fully functioning controller. Okay, so let's, the next thing we'll do is we'll build our little MIDI interface. Actually, before we do that, here's the first thing you should always do whenever you start working with a microcontroller, is make sure you can talk to it, right? All this stuff in the world isn't going to do you any good if you can't send a program to this. So let's plug it in, and we're going to send a little blink program. And I always find that's a good test. All right, so let's open up the Arduino IDE. Just a minute. Where is it? There it is. Okay, let me get back here, and we'll go here. Okay, so here's your IDE. So let's load up the best thing to test with, which is the blink under Sketchbook Example Basics Blink. All right, so that's a really simple program. It blinks the LED. So if you can get the LED to blink on this guy, you know you're at least communicating, and you can load programs into it. So what we have to do next is go to Tools, make sure our board is set to, set to Arduino Nano, right? And our COM port is set correctly. So I believe mine is, this is COM 5. If it's the wrong COM port, you'll get an error message saying you can't talk to the board. So make sure, if you got a couple, make sure you pick the right one. And we should be able to upload. So it's going to compile the sketch. And watch the RxTX lights. And you should see them do a little blink as the code uploads. Yep, I saw it. And as you can see now, our little onboard LED is blinking. So I've just verified that I can add code to this. Great, perfect, we're on our way. Okay, so let's remove power. So it's a good idea when you're wiring stuff up, you know, take the power out. Just saves you from shorting something or something like that. So let's do the MIDI jack first. Okay, so our MIDI jack, and we've done this a million billion times, but we'll do it again. Here's our MIDI jack. It's got five pins on the back, and this is, I'm looking at it from the back. Okay, this diagram. The middle pin will go right to ground. The two outer pins do nothing. We do not connect them to anything. The pin next on the right of ground goes to a 220 ohm resistor and then to our TX pin on our Nano board. So that's 220 ohms, 220K, 220 ohms. And the other side, the pin to the left of the center pin, goes to another 220 ohm resistor and to plus 5 volts coming from the Nano. So that's 220 ohms again. All right, can you see that? All right, simple, done it a million times. You should be able to do it in your sleep. So what we'll do is we're going to port some power and ground from our Nano, and we got to get it to all these different boards. So let's take a little ground wire. Now, if you can see here, there's a pin G and D, right? That's your ground pin. So what I'm going to do is take a wire and put that to the blue strip on my board. So I always like to use the blue for ground, then the red for plus 5 volts or positive voltage. You know, just helps you remember which is which. And the pin, 2 pins over is 5 volts. So we're going to take that and put it to our red positive rail. Okay, so once I'm in there, all this strip is now connected to that, and all the blue strip is connected to ground. Now, since we're using 2 boards, I have to jump this over to the other board as well. So let's take another wire. I think this will work. I need the smaller ones. And connect the 2 grounds together. And so I'm jumping ground from this board to this board, and then jumping plus 5 volts, same way. And I'm actually going to jump the ground on the other end as well, because you can never have enough ground connections. You want a nice solid ground. Okay, so that's basically our power wired up. So now we can wire up our MIDI jack. So let's wire up the middle first. See if I got a bigger wire here. Okay, so middle pin goes directly to ground. I'm going to use this longer brown wire. All right, then we've got a 220 ohm resistor. I'm going to jump the middle of the board from that pin. That will go to our TX pin. We're going to do that in a second. And then our other 220 ohm resistor, we'll jump the other side of the board. Yeah, that's right. And like we said, that's going to go to our positive voltage rail. All right, there we go. So plus 5 volts ground, and we're going to run a wire to the TX pin. Why don't we do it now? Actually, I'm gonna wait for a bit because we haven't got this programmed yet. So I'm just gonna hold off on that for 1 second. Remind me if I don't get back to it. Okay, now our potentiometers. And I'm not I've had these for a while. I think these are 10K linear potentiometers, and I put a knob on them just to be fancy. And the way you wire up potentiometers is very simple. If this is your potentiometer, there's 3 pins. Looking at it with the pins facing you. So the pin on the right will go to plus 5 volt rail. The pin on the left will go to ground. Who's that? Louise. Wow, you got a big name there. Louise, thank you. Thank you for subbing. That's great. Welcome. And so we got 5 volts on the right, ground on the left. Middle pin will go to one of our A analog inputs from A0 to all the way to A7. So any of those inputs. All right. And if you mix up your 5 volts and ground, all that will happen is when you turn the pot, it's going to do, like if you turn it clockwise, the numbers will go down. And if you turn it counterclockwise, the numbers will go up. Usually you want it the other way. So it's not going to hurt anything. It'll just kind of work backwards, which may be a little weird. Okay, so let me show you what I'm doing here. Now, to make my wiring and my life a little easier, who's that? Bellas. Welcome. Thanks for the sub. What I'm doing here is, and this is kind of why I like these pots, all right, is they fit on a breadboard pretty nice. Some don't fit as nicely. You may have to connect wires to them, but these ones kind of fit really nicely in there. So I've got my 3, right, and I got to kind of think a little backwards on this. So let's run some power and ground. So the right hand one here will go to plus 5. And you gotta have really delicate little fingers to get this working. And the other side will go to ground. All right, and we're going to wire up all our signal pins after we put them in place. All right, so let's I gotta fit a lot on this board, so I'm gonna get them as close as I can without touching. I think I have to go one more over. Yeah, that kind of works. Okay, so let's just put them all on before I wire it so I don't have to redo it. And we're going to try 8. I think that was the request, was 8. And that's the number of analog inputs we have anyways, so we can't do more than 8 without help. So I'm just doing a simple controller with this. You know, I'm not using any multiplexers or anything like that because I haven't confirmed they work on the Nano like I want them to. So maybe we'll do that next time. But we're going to make this is going to be, 8 controls, which is a lot, How many controls do you need? Come on. Where are we? How many have I got? I need one more. Okay, so that's a lot of controls. All right, now the fun of wiring, the joy, the absolute thrill of watching someone plug wires into a breadboard. All right. Yeah, it's tight. There we go. So once again, right pin to positive voltage, left pin to ground, center pin, we will jump to our Nano board. Oh, the things I do for you guys. And next one. You know, this may not be the thrilling part, but it's going to get so exciting in a minute. You won't believe it. I was watching Bob Ross marathon on Twitch this weekend, and man, that guy is awesome. You know, the painter guy with the big afro. He is so cool. So I want to be like the Bob Ross of electronics, except without the hair and the patience and the raw talent. So what does Drew say? What about maybe a photoresistor for one of the inputs? Yeah, you could do that if you want to, you know, get into some Blue Man Group kind of stuff. You know, sure, why not? So anything with resistance that works like, you know, a potentiometer that that the Arduino can recognize as analog input, you could use. And faders, you know, linear potentiometers work just as well. So you can use those. They work exact same as pots. Drew, excited you caught you live finally. Thanks, Drew. Awesome. I'm glad you're here. So there's maybe for a filter. Yeah, sure. You know, that's the thing. Like you can get all like Cirque du Soleil performance art stuff going on. You know, you use various appendages to sweep your filter. I'm not gonna say which one. I'll leave that up to you. All right, I think we're almost done this part. And quick double check, make sure I'm not doing anything dumb. I don't think so. Yeah, okay, looks good. All right, so all our powers and grounds are hooked up. And yeah, why not? That was good. That was fun, exciting. So now we're gonna take some of these guys, which are also super useful. So buy them by the truckload if you can. And let's see. So I'm going to do it like this will be A1. Oh, wait a minute. Yeah, this will be A0, 1, 2, 3, 4, 5, 6, 7. And so since these are closer, we'll use some shorter ones. A0 into our middle pin. So you can see kind of why I put the pins on the back, because otherwise I'd have to snake everything through and it would just be even messier than it's going to end up anyways. And next one, A1. Not only a pin, but also a steak sauce. Fun fact for the non-North Americans. And A2. Let me move that over here. See, if I had a nickel for every wire I've put in a breadboard, I'd be really happy. A3, we'll go to this guy. So just remember, we're starting at A0, so A0 to A7. A4. right, and I think we're going to need some longer. One starting now. What do I got here? Yeah, I got 2 long ones. 3. Perfect. Okay, so almost done. All right, this is A5 and A6. And where was that long one? A7. Let's use this one, maybe. No, we gotta use this one. All right, there we go. And our perfectly neat wiring job is done. Cool. Okay, that's great. So, what should we do next? Let's test this out and see if we can get these working at least. Okay. So, what you're gonna want to do is go to everyone's favorite website, notesandvolts.com. So let's see, Joseph, is it possible to use a USB output instead of MIDI? Not for this guy. Okay, I'm going to do that in the future. I'm going to switch to a different platform, do USB MIDI. But for right now, this guy is 5-pin only. 5-pin MIDI only, which isn't a big deal. And I'll show you how to hook it up to your software if I can get everything going. So scroll down until you get to Arduino Midi Controllers, Potentiometers, and download the software here, right? Click on that, and then just download this guy to your desktop. Midi Controller version 1.2. It may be higher if I add some stuff, but you just use whatever the latest one here is. Okay, so I've got it on my desktop already. And once you download it and extract it, you will get this. Okay, three files. What's that, Drew? Radio Shack's going out of biz? Didn't they go out of biz like ages ago? I think they've been going out of business forever. What's that, Joseph? Dave has the answers. Sometimes. So MIDI controller. So open, these two are library files. Who's that? Jarrett has subscribed. Thank you. And someone else has subscribed. James. So open the MIDI. What's that, James? $5. Thanks for all the great tutorials. My God, man. James, thank you. You are awesome. You just helped purchase my Nano. That's so awesome of you. Thank you. Okay, so you're going to get 3 files. Open the Arduino file, Midi controller. So these two are library files that I created to kind of take all the nastiness out of this project. So open that one. And it should pop open in your Arduino software. Okay. So the idea with this, and I don't know how successful I was, but I tried to make things easy for you with this program. So it's kind of like a plug and play kind of thing, and all I have to do is configure some stuff at the beginning of this program. Who's that? Melissa Zile. Welcome. Welcome. Thank you for the sub, man. That's great. Okay, so let's kind of go over what you do. Like, it's simple. It looks kind of intimidating, but it's actually very simple, or so they say. So the first thing you got to do is you go, how many potentiometers are directly connected to pins, right? And all 8 of our potentiometers are connected. So we're going to put this to 8. All right, so that's that done. Then we'll skip down to define directly connected potentiometers. And this is basically, I'm using objects for this, and this is the pot object. So the first parameter is pin number, second one is command, and notice I said command is for future use, so there's only one command right now, so just leave that at 0. The third thing is CC controller number, right? And we're going to set that to the ones we want to use, and the fourth thing is MIDI channel number, and we're going to use channel 1 in this project. So I made some example pots, and all we have to do is uncomment them to make them actual things. And what we'll do is we're going to add 2 more because we're actually using 8 pots on this guy. And we'll name this P07 and this one P08. And our Arduino pin, A0, A1, so we got to go A6 for this guy, and A7. So that's the actual Arduino Nano input we're going into. The next thing we got to do is set some cool controller numbers that we want to control. So what I'm going to do is, since I want to kind of use this to control Ableton, if I was, you know, controlling a synth or something, I could look at the manual and see, you know, maybe, I don't know, controller number 33 is a filter resonance, and then I could use that, right? But for Ableton, I just want to use something that's not going to get in the way of other things. So here's a great site, Nick Fever MIDI CC list. All right. Now, a lot of MIDI CC numbers are already defined to stuff, right? Especially some of these lower ones. And let's see, this is volume, you know, portamento, damper is always 64. So a lot of these are already assigned, and if you kind of reassign them to something else, it may cause weirdness and headaches and what have you. Okay, so let's go down to the bottom. So some of them are undefined, and let's use this range here. So 102 to 119 are undefined. So that means we can use them how we want. What's that, Jorge? Brazil. Welcome from Brazil. So crazy that there's people all over the world watching me ramble like a crazy person in a basement. But I'm thankful. Welcome. Okay, so we'll use 102 to 119 as our controller numbers. And that hopefully will mean we won't step on anything else. So that Dust Boy, it's 3 a.m. here in Sweden. Better get to bed, and I'll check out the rest tomorrow. Have fun, guys. Thanks, Dusk Boy. It's like all the way from Sweden at 3 a.m. My God. Okay, so okay, let's do our CC numbers. Okay, what did we say? We're going to do 102 to 119. So we'll start A0, we'll call it 102, 103, 104, 105, and you know where I'm going with this, 106, 107, 108, 109. Okay, so there we go. We've set our CC controller numbers. Our channels are all 1. Our command, leave it at 0 for now because there ain't nothing else. And the last thing we have to do is this array of pots. We have to include the name of each pot in the array. And I kind of did a little example here. So I'll show you basically what you do. And paste those guys in. So PO1, right, PO2, and you have to put the ampersand sign in front. And I'm going to paste that again and edit them. Get rid of this last comma, right? So it's 4, 5, 6, 7, 8. All right, so that's all our pot objects in this array. And the reason we do that is basically the software kind of uses this array to read through all the pots, and I didn't know how many pots you would be using, so by putting them in the array you can have 1 pot, 2, you know, up to 8, up to more, I think, if you had more inputs. Okay, simple. So just remember, number of pots, set it to your number. Define your pots, right? Define your CC numbers, define your pins, put them in the array. And that should be it. Oh, and one last thing. We got to hook up our TX pin. I told you guys to remind me. All right, TX pin, 2 TX on the board. It's up here. All right. And I think everything else, I think that's all she wrote. Yep. All right, good luck. I'm going to double check, make sure. Always think a little bit before you plug everything in. All right, now let's upload stuff. See what we broke. Yeah, looks like it's going. Watch for the flashies. Perfect. And if I move this, you should see motion on the TX light. And I'm seeing it. Good, great. So the next thing we'll do is we're going to test and make sure. So let's open our MIDI monitor software. And see if we can get messages. So we need our MIDI cable. And I have a MIDI interface hooked up to my computer. And I'm going to go into the MIDI input. So this is a MIDI output on my board. And if I move the pot, look at that. So let's make sure. So first of all, look what I'm getting. So if I move the pot all the way counterclockwise, I'm at 0. So the way you read these things, the first status byte, that's your MIDI CC status byte, right? That's the command for status. The second thing is the actual MIDI CC number, and it's 66. And you may be going, hey man, we set it for like 102, why is it 66? Well, because this is in hexadecimal. We actually use decimal. And I'll kind of show you that in a sec. And the final thing is our number that should go from 0 to 7F, right? And if you're kind of confused by the hexadecimal thing, go to your Windows calculator, go to programmer mode, right? Set it to decimal, and let's type in 102. And what's the hex? 66, right? That's why we're getting 66 on our MIDI monitor, but that's actually decimal 102. All right, so that's good. Next one should be 67, 68, 69. And remember, we're in hex, so instead of 6010, we're going 6A, and then 6B, 6C, 6D. Perfect. Nice. Okay, so that wasn't too painful, was it? Okay, now let's, while we're on a crazy roll here, let's do some buttons. And take the power out. And why don't we disconnect our MIDI? Okay, so let's do some buttons. And buttons are, in a way, even simpler than pots. Okay, so our button, what we have to do is, there's our button, and there's a set of pins here, a set of pins here. So basically these two pins are connected, these two are connected. So we're going to use one here, that's our ground, and this one will go to a digital pin on the Arduino, right? And I think we have like D2 to, how many we have on this? D2 to D12. Yeah, so I think we got 10 pins. So you could do 10 buttons. That's pretty cool. All right, so there's our button. Let's try to squeeze everything in here. And get them in place. All right, make sure they're seated on your board, and we'll connect the lower leg to ground on each one. And second one. Third, fourth. Okay, excellent, great. And we'll use some of our jumper wires. And how shall we do this? Let's move, let's do, yeah, so I'm going to do D2, 3, 4, 5. All right. So I could do 8 buttons. That would probably make the most sense, but 4 is what I got on hand. And one more. Okay, so there's our buttons connected. And let's go back to our MIDI code. And we'll plug our thing in, everything cool. Yep. Okay. So let's define some buttons on our thing, and we basically do it the same way as our pot. So number buttons, we're going to set to 4. Okay. Go down to define directly connected buttons. So for buttons, first is the pin number, right? The second is command, and there's a couple of So Joseph asks, what about pull up, pull down resistors? Are you using the internals? Yes, I am. So part of my program, when you define a button, it actually sets the internal resistor. So these guys have internal resistors, so you don't have to do it. Makes it even simpler. Okay, now on buttons we have some actual commands. So if I use a 0, that's a note command. So it's actually like pushing a key on a keyboard, right? And you can set the note to whatever you want. That's a MIDI note value. If I set it to 1, it's a CC, and if I set it to 2, it's a toggle CC. Now the difference between a normal CC and a toggle, normal, when I press it, it will send a command, and when I release it, it will release the command. Toggle, I press it once and release, it sets it, press it once again, it resets it. So, you know, depending on what you're trying to do, one will be better than the other. And we'll kind of take a look at some examples. So what did our pots, we went to, finished at 109. So let's start with 110. So our buttons, I'm going to uncomment 4 buttons. And pin 2, 3, 4, 5, and that's what we did, right? Digital pin 2 to 5. Let's use our commands. Let's make 1 a MIDI note, 1 a CC. I'll make 2 a CC and 3 a toggle CC, just for an example. And we also have another parameter. This is your channel. We want MIDI channel 1. And there's one more parameter, is debounce time. So this code also has a built-in debounce code. So this is the number of milliseconds it's going to debounce the button. The higher you do, the more it's going to debounce, but could add some lag to your button press. So I found 5 for these type of buttons is pretty good. If you find you're getting multiple messages for one button hit, then you can increase that a little bit. All right, what was I talking? 110 for our number, 111, 112, 113. And everything looks good. Yes, yes. And the last thing we have to do is we have to add it to our array, just like we did before. All right, cool. So that's done. That's done. I set the number. That's done. So set the number, define your buttons, and put them in the array, and upload. And let's see, everything looks good. Watch the flashies. Yes. And let's pull up our MIDI monitor again. Plug it in. And this guy, yeah, so you notice that one we set as a note on. And when I press it, I get a note on. When I release it, I get a note off. Okay, perfect. Second one, CC. And the way a CC works as a kind of toggle is, you notice when I press it, it goes up to 7F. And let me show you something, because this is important. So, you know, when we're using our pots, we're basically using a variable CC number, right? From 0 to 127. But when we use a button, we're just using an on and off state. And if we look for some guy here, so you notice like this one here is an on and off switch. If my number is 0 to 63, it's off. And if it's 64 to 127, it's on. So any number in this range is off, any number in this range is on. So when I go back here, when I press this, oops, do a CC. Notice when I pressed it, it was 7F, which is 127, which is way up there, and 0 for off. Okay, and that one was also CC, and the last one is toggle. So you notice I press it once, it's on. I press it again, it's off. Right? So that's what a toggle does. All right, simple. So before we go on to Ableton, I'm going to set this button to a controller. And yeah, so let's make that a 1. And I usually unplug my MIDI cable because the TX line shares the serial port that's bringing code in, so I'll get a lot of garbage coming out, which isn't normally a big deal, but you know, if you've got a synth hooked up, maybe you don't want to send all that. It might change some parameters or do something weird you don't want it to do. While I'm doing that, I'm going to get a drink of water. Do we upload? Are we done? Yes, we're done. And let's just test it. Good. Excellent. Okay, so that looks like a MIDI controller to me. I don't know about you guys, but I think that's pretty good. Okay, so let's get rid of our MIDI monitor. And let's get rid of that. Let's get rid of that. And let's start Ableton. Okay, so here's our Ableton interface. Now, Ableton is really cool in the way it maps control parameters to stuff. Okay, so it's really simple to do. So the first thing you got to do is you go to Preferences. Where is it? Where's Preferences? Preferences. There you go. And here's you go to Link MIDI. Now you notice I'm using an 8 input MIDI interface. It's a Mark of the Unicorn. I don't know the number, but it's 8. It's got 8 MIDI ports on it. So what you have to do is make sure that remote is set to on as an input. Okay, because that's going to allow us to use our controller as a controller. And that's good. Next thing you do is you go to MIDI, this little button here, and you notice everything turns blue. Let me do a full screen here. So we're going to run out of space. Okay, so everything turns blue, and all you have to do, and this is super cool, is click on the knob you want. So say this potentiometer, and turn the dial that you want to control it. And now you see our MIDI CC is 102, which is what we set that to. And if I disable MIDI mode, go back to normal, you can see now, let me do this view. As I turn the pod, this fader is turning along with it. Right? That's pretty cool. So, Alexandra, what's the name of the console app that monitors the MIDI event? It's called Midi OX. OX. A really good program. So, you know, you can download that, and I think it's like free, but you can donate to the guy if you want, and it's really useful. So use that one if you're on Windows, of course. Okay, so pretty cool. So that pot is there. let's do another one. MIDI. So let's do the next pot over, and we'll use this guy. And now we've got this guy controlling this. Second one is controlling this. Nice. And let's do some more. Let's do this slider on number 3. And let's do this slider on number 4. All right. And let's see how that works. So number 3 is this slider. Right? Number 4 is this slider. And you can see you can go nuts with this stuff. And the cool thing is you can even do effects too, right? So if say I had an effect on this channel, I think you can map the effects to knobs as well. So that's that one, that's that one, that's this one, and that's this one. So you notice now, as I do these last 4 knobs, I'm actually controlling the effects. You know, super cool, like, and real easy to set up. Okay, so hopefully that makes kind of sense what I did there. Now let's do the buttons, all right? So basically the same deal, you know, select your MIDI input mode and select a button. So let's do let's do solo on each channel, okay? And I'll show you a little something. So solo, right? And there we go. So as I press button 1, solo 1 goes on, solo 2, solo 3, solo 4. All right, so that's kind of cool. Now, I want to find something that kind of toggles. Let me try this. So if we go to MIDI, and you can also kind of control, like if you don't like something, just like click on the button and you can delete what you did. Now, so my final button, I'm going to use the, actually let me show you this. So I'm going to delete all those I did, and I'm going to do the track enable. Now let's, I think that will, all right. Now notice, I don't know if you can see that, as I click this guy, you notice as I release it, it goes gray and then it goes not gray, right? So it's not sticking, and that's where our toggle button will come in play. So this one's the same, but this one, you notice as I press it, it toggles on, and I press it again, it toggles off. So if you're controlling something with a toggle kind of idea, so on an actual controller, you know, you click the button down and then you click it again to take it off. You need to use that toggle function for it to stick. Otherwise, you get like just a momentary kind of thing. Right, yeah, that's better, you can see it. So if there's 1, right, doesn't stick. There's 2, doesn't stick. 3 doesn't stick. 4 does stick because we set it as a toggle. All right, that's pretty cool. I gotta say myself. So, you know, think about it. You got, you know, $5 Arduino board. You got some potentiometers, you know, a couple of bucks each. You got some buttons, like less than $1 each, some wires, a MIDI jack, and you got a fully functional MIDI controller. You could put this in a box now. Now, one thing, other thing to think about. Right now we're powering this guy from USB, right? Which is fine and it works, but maybe you don't want to do that. If you're making like a performance kind of box you want to take on stage or whatever, you may want to power it from an external power source. So once the code is loaded on this, you know, USB is just providing power. You don't need to have it anymore. So the Nano, and I'd have to verify, but there's a VIN pin somewhere. Yeah, the first pin here is VIN, and I think that's the regulated pin. So you can put like I think the range is about 6 to, I don't know, say 10 volts. You, like, verify it, go to a Nano site and verify this information. But you put the voltage in there from a power supply, it's going to go through the regulator and convert it down to 5 volts. There's also a 5 volt pin. I think you can put a regulated 5 volts in there, but once again, double check, go to the Nano site and Google how to externally power an Arduino Nano, right? That way you don't need your USB cable, put it in a box, hook a power supply to it, and there you go, right? You're done. So guys, what do you think? I think that's pretty good. So, you know, not too hard. I think anyone could do this, and hopefully that kind of explains it, you know, for people who can't kind of see the whole picture. We went from beginning to end, how to control software. There you go. So was Joseph, one can go crazy with the possibilities? Yes, you can, and I have gone crazy a long time ago. I think you were right, but it's a good idea to double check that. Yes, double check. You know, I'm going off the top of my head, you know, but double check everything. All right, guys. Any questions? Any comments? Anyone? Any? Or did I just do it so perfectly that, you know, there's nothing left to say? Because if that's the case, that's the absolute first time for that. So, okay, seeing nothing. So that's pretty cool. I think we'll call it a night. Hopefully this inspires you to build your own stuff, a simple little cheap controller. We'll look at, I'll have to research multiplexers. If you need more than this, you can use a multiplexer, but I'm gonna have to make sure it all works like I think it does. What was that? Joe says, I thought it was a good idea, another crossover for ground. Yeah, you know, like ground is the cause and the solution to 99% of your problems in electronics. James, great stream, Dave. Did you plan to do another one on the Teensy? Yes, I do. So what I want to do is I want to port this code over the Teensy because it's a little faster, a little more functionality, and it's got a really nice USB Midi component, so we can actually do USB Midi instead of our 5-pin. All right. You know, I know there's hairless MIDI for the Arduino and some other things, and I just don't even want to get involved in them. Like, you know, I've looked at them and it's like, you know, I'd rather something that's kind of purpose built for it, and the Teensy kind of fits that bill a little better. Matthew, can I connect a piezo mic as a trigger? Yes, you can. So basically anything that's going to trigger a analog input on your Arduino, you can use. So as long as the Arduino can recognize it as a you know, a valid source, then you can use it, right? All we're doing is triggering an analog input. So yeah, you can. There's a little, you Google piezo triggers, and it's a little more involved, and my software won't natively handle it, you know, so, you know, Google it, check it out. Let's see, Kinzos says, can do MIDI, USB MIDI with Arduino Micro as well. And that's, you know, I haven't played with the Micro, but as far as I know, that you have to do some finagling with stuff, whereas the Teensy, it's kind of built in, so it kind of works a little better. But, you know, double check. Once again, I'm talking off the top of my head. You know, double check. And my code wouldn't handle USB MIDI natively. So I'd have to update the program, and it's kind of a different topic. So we're going to get into that, but I got to wrap my head around it a little bit first. All right, guys, that's awesome. Once again, check out, you know, subscribe on YouTube if you haven't already. Twitter, all those different fun sites. Go to the YouTube page or my notesandvolts.com, and lots of information. I am an Amazon affiliate. I'm going to put some Amazon links in the description where I bought my Nano. And if you use that to buy your Nano, you know, I get a couple of pennies, so that's really helpful. Also, I have a Patreon page. If you really like my stuff, you know, helping, that really helps too. Super helpful. Love nuts. Notes. Was that a typo, Matthew? Let's see. Kinzo says it's actually really easy with the right library. I think it's USB MIDI. Yeah, so it could be. So, you know, double check that. I haven't got into that yet, but I will be looking into that in a bit. So anyways, guys, it was a lot of fun once again. Nice hanging out with you guys. I hope you have a great week, and I will see you next time. So until then, have fun, go make some noise. Have a good night.